So what I want to talk about today is corresponding parts of congruent triangles. When you have congruent triangles, you have these 6 parts which are congruent to each other. A side from one triangle congruent to a side from the other triangle. Another side congruent to another side. A third side congruent to a third side. You also have one angle congruent to another angle. A second angle congruent to a second angle. And a third angle congruent to a third angle. So you have all these 6 congruency pairs to pull from, and these are the corresponding parts of the congruent triangles. So our question for the day is, how can triangle congruency be used to prove segments or angles are congruent? Now, when we want to prove that a segment is congruent, oftentimes it's easier to find a triangle that contains that segment and another triangle that contains the other segment, and to prove those triangles are congruent. Then after we prove they're congruent, we say, hey, yeah, by the way, these two sides, because everything is congruent in these triangles, these corresponding sides are also congruent. Well, that's what we're going to learn about today. Before we get into that, though, I just want to review some things from our last lesson. From the last 2 lessons, I want to summarize these triangle shortcuts. So we learned about congruency shortcuts. We learned that there were 4 that were real shortcuts. You only had to find 3 congruencies, and then you got all 6 triangle congruencies. Those are side, 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 angle, side, angle, angle, side, which is the same as side, angle, angle. In both of those cases, you have 2 angles, and the side is outside of those 2 angles, not between them. And angle, side, angle. The ones that were not shortcuts were side, side, angle, which is the same thing as angle, side, side, and also angle, angle, angle. Now, when I memorize which are triangle shortcuts and which are not, I just memorize the ones which are not. I know that AAA is not, because when I have 3 angles congruent, it doesn't tell me anything about the side length, so I can have really big sides or I can have really small sides. You get a mama and a baby, and that's not a congruency. And then it's easy for me to remember the other one, because angle, side, side makes that nice little acronym there. I just have to remember that that's the same as side, side, angle, and those are the only ones that don't work. If I make any other set of triangle congruencies, it is a shortcut. I just remember the ones which are not, and that helps me remember which. If I have any other triangle shortcut, I know that that works. So, if we want to prove a segment or angle is congruent, I'm going to find a triangle that contains these 2 segments, and I'm going to try to prove that those triangles are congruent with one of my shortcuts. Once I do that, then I'm going to say, so these particular angles must be congruent, since the whole triangle is congruent. We use this in proofs over and over again. In the next 2 sections, we're going to be studying how to do proofs. And in lots of proofs where you're trying to prove segments or angles are congruent, you use CPCTC in order to do this. Now, CPCTC, you have to say it really fast like that. CPCTC, CPCTC. That stands for, it's an acronym standing for corresponding parts of congruent triangles are congruent. In other words, if a whole triangle is congruent, then these 2 sides of the triangle are congruent to each other. It's just highlighting one congruency pair in each one of your triangles. When you have a proof, very often you're going to prove the triangles are congruent, and in the last step you're going to say, so these angles are congruent, and that's by CPCTC. That's the reason you give for that last step. Remember, when you're doing a proof, every time you give a statement, you have to give a reason, and this is the reason that is used oftentimes in the last step in your proof. So let's take a look at one of these and see if we can work out a paragraph proof here. I'm trying to prove that segment AE is congruent to segment BD. Now, when I first look at this picture, I notice that it's very complicated. There's many triangles in here, many different triangles. At least 6 different triangles that I see. And so what I'm going to do first of all is I'm going to split out these 2 triangles, And so I'm looking for a triangle that has AE in it, and I'm looking for a triangle that has DB in it. I'm trying to think, okay, how could I split these two triangles out? So here I can see, let's see, here's DB right here, and here's a triangle that has that in it. So I'm going to take that one, and I see another triangle that has AE in it that looks like it might be something, and that's this one right here. There's a triangle right there. So I'm going to take those two, and I'm going to split them out into, I'm going to draw them here. Whenever I have a complicated diagram, oftentimes I will redraw them. So I'm going to redraw these so that I get these two here. So you can see what I've done is I've taken one triangle, I've taken this triangle right here, and I have redrawn it over here, and I've put all the markings in that go with it. And then I've taken this triangle right here, I've redrawn it as well, and I put it right down here. This helps me to see kind of what's going on. Now, behind every proof there's an idea, and I want to talk about the idea of this proof first. So I have these two triangles once I split them out this way, and with these two triangles what I'm hoping to do is prove that they're congruent. See, I want to prove that AE is congruent to BD, but the way I'm going to do that is I'm going to prove that the triangles are congruent first, and then I'm going to say, oh yeah, by the way, AE and DB are congruent to each other because they're both one corresponding side of this triangle congruency pair. So if I'm trying to use a shortcut to do this, I see that I have two congruencies already. I have angle D is congruent to angle E, so there's an angle congruency. And then I have angle B is congruent to angle A, another angle congruency. I need something else. So I'm wondering if anyone here can see that there is another side that is congruent. Can you look up here and find a side which is congruent? So I hope you see that AB is in both of these triangles, and AB is obviously the same side, so it's going to be congruent to itself. So I'm going to say, well, this is the third side here. So I have two angles that are congruent to each other. The side is not between my two angles. The side is across from my two angles. And that means if I were going to write this as a triangle congruency shortcut, it's going to be angle, angle, side, which is the same thing as side, angle, angle. So both of these are triangle congruencies. This isn't any of my shortcuts that don't work. It's not AAA, and it is not SSA. And so I know that this is a triangle congruency, and sure enough, that's going to work. So this helps me know that everything's going to work out fine. I just now need to write a formal proof here. So let's take a shot at writing our proof then for this particular statement. So I'm trying to prove that DB, or line segment DB, is congruent to line segment BD is congruent to AE. So the first thing I'm going to do is talk about the things that I know from this proof. I'm going to talk about the fact that I know that angle D is congruent to angle E. And I'm also going to say that angle B is congruent to angle A. Now these were both part of my original problem, and so when I explain, remember when you have a proof you're going to have a statement and then a reason. When I explain the reason for these, I'm just going to say that these were given. Given is the code word for the fact that these were present in the problem. I got to start with these ideas. Now, if you'll remember, I added in the idea that AB was congruent to AB. So I'm going to add that in to the marking here. So here, this one and this one are going to be congruent to each other. And the reason that those two things are congruent to each other, I'm going to say AB is congruent to AB. Now it's interesting, in math we actually have a reason why something is congruent to itself. We have a reason why 5 is equal to 5, for example, and we call that the reflexive property. By the reflexive property. See how reflexive is like a reflective? It kind of is like a mirror. And it means that things are congruent to themselves or things are equal to themselves, depending on whether it's a number or a side. But it means that everything is equal to itself. Everything reflects itself and works there. So you can see now what I've got here. So up here I've got an angle. D and E are angles. B and A are angles. And here I've got a side. And that side is not between the angles. And this shows me, see how I've listed? I have statements up here for an angle, statement for an angle, statement for a side. That means that I have listed out all parts of my triangle shortcut. So now I'm going to write in the fact that these triangles are congruent to each other. So I'm going to say triangle, and I'm going to say BDA is congruent to triangle. Now I have to make sure I get my letters right here. The angle that's congruent to B on my second triangle is A. The angle that's congruent to D on my second triangle is E. And then I just have a B that's left over here. So I get triangle BDA is congruent to triangle AEB. And this is by my angle side, which is the same thing as side angle. You don't have to put both. I just put both up there so that you realize that either way is perfectly fine. So now I have the triangles are congruent. Now what I was trying to prove when I started off here, I was trying to show that that BD, which is this side, is congruent to this side, which is AE. That's what I was trying to prove. Well, now I've proven that these triangles are congruent to each other, which means all these sides are congruent to each other. And all these angles are congruent to each other. In particular, I know now that BD, that segment, has got to be congruent to AE, that segment. And how do I know this? This is by CPCTC. By the fact that since the triangles are congruent, then corresponding points have to be congruent too. And that is the entire paragraph proof.